Welcome everyone to this webinar. My name is Michael Snoyman. This webinar is being put on by FP Complete, and we have one of our engineers, Roman Gonzalez, will be presenting today on development workflows in Haskell. At this point, Roman, I'm going to pass it over to you. Please take it away.
Thank you, Michael. Hello, everyone. My name is Roman, and I work at FP Complete. And today we're going to be focusing on showcasing workflows in Haskell. So I have a few goals with this webinar. The first one is, why do we need to focus a bit on Haskell development workflows? What is so important to have a really good streamlined workflow? So understanding the importance of fast feedback loops for that. Also, enumerate the differences between compiled and interpreted workflows, given that Haskell is a language that works both in compiled and interpreted fashion. You have different options there. Learn about different tools for effective workflows. This webinar is going to be focusing on editor-agnostic tools so that everyone can take advantage of the webinar. Learn GACI basics, some useful settings and capabilities. GACI, a lot of people just cover the basics of GACI, but it has a lot of things to offer and a lot of information that you can get out of it. So we're going to focus a bit on understanding what are all these utilities. Also, follow through different examples that showcase different workflows. By the end of this webinar, we're going to have gone at least through 2 projects, one small and one big. And we're going to try to use the different workflows on both of them just to see how things behave. A bit of a disclaimer. We are assuming in this webinar that you are familiar with the stack tool. We are going to make heavily use of this tool. There are other tools that are similar in capabilities, and you're welcome to use them. Here, we are presenting tools that most of the FP Complete developers use on a day-to-day basis. With that disclaimer, let's get started with feedback loops. So whenever we are doing work, imagine you have been doing it for, say, 4 hours. You have been coding for 4 hours, really in the zone at times. But every time you modify the file, you need to either compile the code or run some tests to see that what you're doing is actually useful or effective. This in itself is not challenging. Just switching a tab, pressing the up arrow, and then running a command is not a challenging task, but it's a taxing one. After a while, you spend a lot of time just in that motion, and it gets you tired eventually. Your brain can do so much of that for long periods of time. So these tiny bits of repetition add up as time progresses. On the other hand, if feedback is fast and automatic, you can iterate through many effective changes without thinking about it too much. So just to be clear, you can also get the same benefits by just manually doing things, but you're probably going to be more tired by the end of it. Ideally, you want to be able to see what changes your code changes are doing, what are the side effects, or sorry, the effects of your code changes as soon as possible. So if you want to be able to get in the zone more often, you have to pay really close attention to fast feedback loops. So what is a feedback loop? A feedback loop is the action of, in this context, is the action of modifying a file and seeing a change and adapt your coding regarding to what you saw with that change. If you see a compilation error, you know how to fix it. If you see something working, then you know you can work on the next thing. That's what a feedback loop is in this context. And these are pretty important. So we're going to get started with workflows via compilation. These are ways to do the feedback loops using compiled Haskell. So the first thing we're going to be looking at is the stack toolset build capabilities. You have different options here, and most of them, like it comes already with one file watch option, which is really useful. And what I'm going to do now is just show you how that works. So if I go and I have a project, open source project that it's say 20 modules. It's not too big. I'm going to go and execute fast file watch in here just to see how that looks like. So we see everything works. And as soon as I modify a file here, things are working as expected. If I go and add a typo of some sort, then we would see things compiling and having an error here. So look at the speed of this is pretty fast, right? Like we are able to modify things, and as soon as we have something visible in here, we can know that code is compiling as expected. This is a great start. Given that the project is not too big, the feedback loop is quite fast. But we can do other things as well, not just compiling the code. So say we want to, say we want to test the code. Sorry. If we go and write here test instead, it will automatically do what we were doing before, but will also execute the test suite at the same time, which is really useful when you're working on, say if I save here, test is not being displayed, the test suite results not being displayed, but as soon as I modify the test suite, something is going to happen here. So I'm just gonna go and do spec here, where I'm just going to one particular spec, and let's say should throw, let's just modify this input and see things starting to fail as soon as that happens. So as soon as that happens, we have a failure there, 26 examples, 1 failure. So ideally, you want to make use of this tool of stack build with compilation as soon as possible. If you're not doing anything, you can do other things as well as build documentation. And yeah, let's keep going with the presentation here. You can also, besides getting test suites executed or the code compiled, you can execute scripts after something has finished. So for example, in here, if I want to execute a script, I have a script here that executes this command line, Emacs client, which is a way to communicate to my Emacs program and execute this line of code. If I go and I do exec script, this H in here, stack build test. Oh, I know what it is. It's there we are. Sorry about that. Okay, so as soon as you saw that flash had happening there, every time I have something compiling correctly, I'm gonna have that green mod bar going in, and that's just the bash script executing after the compilation works correctly. If I go and modify this, it will take a while to compile, but in the end, it's going to fail and it's not going to highlight anything. So this is a way to, for in my particular setup, to communicate with my editor, in this case Emacs, and send a signal so that I can see what's going on. You can have other scripts like, say, send an alert to the operating systems. There are different tools that allows you to do that, which are outside of the scope of this presentation, but ideally it gives you ideas of how can you improve your workflow so that you can see what's going on without having to actually look at this terminal, right? Okay. So what are the things that we learn here? When we are doing these kinds of development, we don't have a chance to experiment with code on the fly. It's not like I can write some code and test it right there. I have to either write a test suite or I just can see how it compiles. The time for compilation becomes rather slow on huge projects. We're going to see later on how things work with the Cardano code base, which is a massive project, and see how the times are in that situation. But for most projects, this workflow works just fine. Saving a file automatically recompiles code, automated feedback loop. You don't have to think about having to switch a tab or anything of the like and just pressing a command every time. These things happen automatically as you develop. And this happens on any editor. Like it could happen on a Vim editor, on a Visual Code Text, Visual Studio Code, sorry. And the idea is try to rely on tools that give you that for free. Okay, so now we get into the interesting stuff, the workflows via REPL. So to get started, it's pretty easy. I'm just gonna go to this, and I'm just gonna go and execute stack REPL in here. So you will notice that I have a compilation error here on the spec in here. Let me just switch a different target, and we will look at what target means in this context. But yeah, like at this point, we have all the modules loaded. It took about 2 seconds to load a 22 module project. Let's see what we can do here. So if we do help, we have a bunch of information in here that is really useful. We're going to focus on a few things in here, right? So ideally, the first thing we want to look at is at this show modules, which is a really useful one. It shows me all the different modules that are loaded in the REPL at the current point in time, and also if they're compiled or interpreted. We will see later on that when it's compiled, it won't say interpreted here, but it would say the location of the dot object of the compiled module. So that's the first thing that we can do. Just look at what it's in this context at this current point in time. We can, as you can see, like there's another one that is called show paths, which is really useful. It shows us what is the current working directory that we're standing on, and also what are all the different module paths that we can load or import. In this case, we have everything that is on the source folder, or everything that is on the autogen and global autogen from the project. These are Cabal-generated files. But one thing that is really interesting is we only have certain paths, and sometimes we're doing test suite and code of our library at the same time. So first of all, before going into how can we load both of them, let's go and try to load some modules in here. So the idea is—
Roman, one question from the audience that I wanted to pass along. Is there some way to disable the display of the file names in addition to the module names in that list?
So on this show modules output, or just on the prompt in general?
I believe we're talking about in that show modules output.
Sadly, the output comes from GACI, and there's no way to customize that. But that in itself is still important, because that path over there tells you more information later on if it is compiled or interpreted. Like that tuple that you see with the path and the interpreted message, it's going to be important later on for you to see that, so you know if code is being compiled or interpreted.
Cool, thank you.
No problems. So what I was going to show you is how to load a module in here. And one benefit of GACI is that you can tab in here, and you can get a completion not just of module names, but also files. So load independently of the input that you give it if it is a file or if it is a module, it will understand both. So in this case, for example, if I say I want to load the internal spec types, I can do that, right? And if I do show modules now, you will notice that it's only that module being loaded. If I want to go ahead and not do the module name, but do the file, if I do colon in here and a shell command, it will actually execute it. So in here, I'm just doing an ls. I can see where all my directories on the current directory. Remember again, if we do show paths, we would see what is our current directory. Our current directory is Haskell, etc. And if we go and do an ls, we would see all these different folders in here. You may notice also that the source folder is inside etc. source. So if I go and I do something like load etc. source, I can do tab and it will automatically autocomplete for me things. And I can go and say, okay, I want internal, I want spec, and I want types. This is exactly the same as I did before with the module name. So load is a really versatile in a way because it allows me to both have the module name with the prefixes and dots, or the path of the module on the file system, right? So if I try to say load the test from here, what will happen? Like, let me go into the test folder, etc., and do spec in here. You will notice that it automatically shows me some errors, and most of them are in regards to dependencies. The fact of the matter is that the linker, if I go and show the linker, it shows me all the different things that are imported, and the packages for testing are not one of them. How can I do to add the dependencies of the test in my REPL environment? Well, luckily, Stack has really good utilities for that. If I go and exit this Stack REPL, I can go and look and execute Stack REPL with the different targets that I need in the REPL environment. So what are targets? If I go and I do Stack ID targets, it will show me all the different Cabal targets that I have on this project. So this project right now, let me show you really quickly the stack.yaml so that you can get an idea of how this thing looks like.
Before moving on to that, Roman, one other question from the audience. Is there some way that we can unload a module that's already been loaded?
There is a way to unload modules that you imported, like I say, a third-party module. If you want to unload the module that you're currently working on, you just have to load other module. There's no way to come to an environment where there's ways to come to an environment where you don't have any module loaded. I can go through that in just a second. I'm gonna finish this thought and then gonna go through that. So as I was saying, this project has 1, 2, 3, 5 targets, right? And some of them are on the etc. prefix, some of them are on the etc. CLI, and some of them are on the etc. spec as example. Why is that? Every time we have a Stack project and we define the packages, each of these prefixes of targets is maps with one of these folders. Each of this is a Cabal project that has a bunch of Cabal symbols associated to them. So if I go, for example, the etc. Folder, and I look up at the package.yaml, you will notice that I have a library here, and I have a test suite and no executables. So you would see in the targets over here that I have etc. lib and I have etc. test with the name of the test suite that is part of the Cabal project. So that in itself tells me, okay, if I use these 2 symbols, I'm going to be able to load all the dependencies required for those targets to work. And that's what I'm going to do. I'm going to go and I'm going to write stack REPL, etc. lib, and etc. test, etc. spec tests. And as soon as I do that, it would load not 22, but 28 modules. And if I go and look up at the paths, you will notice that now it has the source and the test folders on its module import search path. And this is because the test directory is part of the source tiers of the etc. spec test Cabal target, and the source tier is part of the library Cabal target of the etc. library. Now, if I go and try to import the file that I was telling you a second ago, things work as expected, right? This is really useful because as soon as I'm able to do this, say I go and I import test hspec. If I go show imports, it will show me all the things that are imported. Right now, I have imported Rio. I have imported a pretty printer, hspec, and the module. And if I go and I do hspec spec, I'm able to execute the tests on the REPL automatically. So what is a great workflow here? A great workflow is to be able to modify a file. Like one loads the, say, in this case, the spec. Let me see what's the module exported. Let's load in here. Let's say with load etc. spec. And I go here and I look up at the spec.hs. I'm able to modify this file, reload here, and see what are the things that have changed with the code changes that I'm doing. In this particular example, it's not too clear because spec is a really upper level module. But the idea is you can quickly go through each of them, each of the modules, and modify them in a unit basis, and then run the unit tests on the REPL automatically. So to cover the question that was asked a second ago, if I go and I say, for example, modify the working directory, if I go and I say, for example, right now I'm on etc., right? If I go and I say I want to go to the etc. folder, I can just do change directory, etc. Notice I'm not using the bang, so this is a particular comment of the REPL. As soon as I do that, it tells you that it causes all loaded modules to be unloaded. So I don't necessarily know a way to unload a module and just stay in the same folder. I know that as soon as I change the folder, all the modules get unloaded. I don't know if that's the best answer to give, but this is a solution for your problem for sure. And again, as soon as you're in there, you can actually load from the etc. folder instead. So before I was using etc. source, I just need to use source now. And things will keep working as expected. Okay.
And actually, two more questions have come in. So another one is there a way that you can run a single test or a set of tests instead of running the entire test suite?
Yeah, like at this point in time where you see me here, like if I go back to load the etc. spec, you see me here doing a spec. I'm right now running just the tests of that module. If I go and I look up a spec in here, you notice I have a spec variable in here, a spec definition in here, and it has only this particular things. Say I want for some reason to just execute this test, I can go ahead and move this into a variable, foobar, and then write foobar in here, and that will be the same thing. So if I do that, and I save and reload, I think I have this is the challenges of doing live coding, eh? So if I go, say for a second here that I comment this, and I reload, of course. Reload, okay, and if I go spec foobar, I'm just testing that particular test, right? So I have ways to actually just test the stuff that I need on the REPL. Okay.
Okay, a few more questions, and then we can move on. The one question I'll answer instead is stack REPL the same as stack GHCI? Yes, they're synonyms for each other. They do exactly the same thing. Another one is there a way for the REPL to recognize changes in the package.yaml file, or for that matter, for the Cabal file, and possibly pull and compile the new dependencies? As far as I know, there's no way to get that done. I believe you have to exit the REPL and then restart by calling stack GHCI again. And then one final actually comment. It seems like there is a way to unload modules. If you do :m and then minus with the module name, that should be able to unload a specific module.
That's interesting because with :m, you load third-party libraries, not so much the ones that you're working on. There's a difference between execute and load and M. With M-, you unload a third-party library, but I'm not sure that will work for the load itself. That's like it's something that we need to test to be sure. But I think it's better just to keep going because otherwise we're not going to have time to finish this presentation.
Okay, very good.
Okay. So we have seen some of this so far. When on the REPL, you can query where you're located with show paths, and also you can move around using CD. We have seen examples of all this. Also, I didn't show the linker. You notice that it has way more content. But the important thing is that the packages that you have over there are defined. So these are all the symbols that the linker understands. And here are the dependencies, the packages that your environment actually have in the project right now. So yeah, it's pretty useful information to know how to get. Okay. So far we have been talking about interpreted Haskell, but there's also a way to get compiled Haskell in the REPL. And sometimes you might want to do that for different reasons. First, one of the reasons might be because your project is huge, and every time you execute the REPL on a huge project, it's going to interpret the files every time. When you do object code, it will compile it only once, and it's going to use whatever is there on the object files. That's one of the benefits. The other one is you get to your code to execute a bit faster because it's not interpreted, although that's negligible in my experience. And that's pretty much it in my list, in my experience of benefits. So let's go and see how that works. Let's go and execute here stack REPL GACI options object code. So the first thing you will notice, let me just do a lib, sorry about that. Cetera lib. The first thing you will notice is that in here, before it said interpreted, like you see that it has a .o in all the different modules. Before, if you didn't execute the object code, it would say interpreted. There's also a way to know what has changed by the means of doing show modules. Before, you know, it said the file name and interpreted. Now it tells you what's the file name and the place where the .o file is. So this particular example, the .o file is in the stack work o there directory. So that's the first change as soon as you use the object code flag in here. The behavior is going to be more or less the same. There are a few small differences. Like, for example, if I go and I look up at one package that doesn't have, like, say in this example, I'm exporting a spec. I'm going to go and kill this REPL again, add the test target to it so I can load both the library and the test. And then I'm going to browse, etc. spec. So browse is a utility that allows me to inspect what are the symbols inside a module. This one is really useful. When I'm using browse, etc. spec, you may notice that the only thing that it shows is the etc. spec symbol. And that's because that's the only thing that we have exported. I can go ahead and do something pretty cool, that is set, instead of having object code, to go back to bytecode. That means it's going to be interpreted again. And if I go and I load etc. spec, and I do show or browse etc. spec, am I exporting anything else in here? Yeah, like at this point, it's not. Let me see something in here. Show etc. spec. Show module, sorry. We will have the .os everywhere. Oh, it didn't actually load it. Okay, I have to modify the file, load. And now the first thing you will notice is it's saying interpreted in here. Like after I did the F bytecode, it changed this to interpreted. If I go and I look up now at the browse of etc. spec, in theory, it should show me all the different symbols that it exports. In this particular example, it's not doing that. I need to figure out why is that. But the fact of the matter is, I'm able to move in between bytecode and interpreted code quite easily by just doing object code in here or bytecode. And this is pretty handy for a few reasons, because it allows you to, as soon as you use bytecode, the compilation is going to be faster, right? Like, or not the compilation, interpretation is going to be faster. Execution is going to be slower. Interpretation is going to be faster. And the object code execution is going to be faster, but compilation is going to be slower. So you can do trade-offs in between what works best for you. This doesn't make too much of a difference when you have small projects, but with really big projects like the Cardano one, it definitely it's recommended. So that's object code and bytecode. Another thing that is pretty useful is sometimes you are trying to say require a dependency that is not there. Like say, for example, I want to import data map strict. The first thing it's going to tell me is it's not there. But you know, because some of your dependencies depend on that containers package, you know that the package is there. It's just that it's not visible. You can, if you can add the dependency to your Cabal file and reload the REPL. That's one option. But another option that you can have is you can actually say, you can write down that, and by doing, oh, sorry, it's set package, sorry. You can do set package containers. And as soon as you do that, it tells you package flags have changed, resetting and loading new packages. Now, if I do data map strict, things are working. So you can, and this is a practice that I normally do when I'm testing stuff and I don't want to be bugged by having to restart the REPL again. I can just add the package to the linker by just doing set dash package and the name of the package. This is really useful when developing software in the REPL. Okay. Another thing that is pretty useful, it's being able to add language pragmas on the fly. So right now, if I look at, right now, I think I have the overloaded strings, but I'm going to disable it for now. No overloaded strings. If I go and I import qualified data.text as text, it tells me, oh, I don't have data on the containers. Oh, that's easy. I can just do that and then import data.text as text. Things are working as expected. And then I can say text to upper, hello, and tells you, oh, I don't understand this. And this is because you don't have overloaded strings language pragma. You can add it dynamically or remove it dynamically by just doing set I-X and the name of the language pragma. So in this case, overloaded strings. As soon as I do that, if I do text to upper, things are going to work as expected. So that's another one that is really useful to know. And we also have set I and set alone. What are the differences between the two? Set I is used for interpret mode only. So most of the times you want to use set I for language pragmas that work only on the REPL, not on the code that you're compiling. So whatever modification that you're doing only to your local REPL in terms of behavior, it's better to use a set I for that. Okay, moving on. Another thing that is pretty useful that is already enabled in this REPL is the set plus S and plus T that will automatically do two things for you. So let's see how it looks like without those. Oh, I don't know how to disable that. Okay, it's okay. We can see. If I do any expression, I will get, first of all, the bounded variable it with what the type is. In this case, it's num_p to p, and the amount of time that it took with the number of bytes that it required in order to execute, right? When you don't have plus S and plus T, that information is not available. As soon as you just do 5 plus 5, you're just going to return 10, and that's it. Every time, as soon as you do set plus S and set plus T, set plus S would add the timing and the size. Set plus T will add the type at the very end, so you can see what's the resulting type of an operation. Those are pretty handy to always have enabled. So how can you do to have those enabled? That's where GACI files come in. So when GACI runs for the first time, it will look up files on different places. The first place that it's going to look at is your .gaci inside your project. And the second place that it's going to look up is at your home directory for a .gaci. In that .gaci file, you can have different modification settings. So, for example, let's go to my .gaci. In here, the first thing that I do is set the prompt to something that is not all the modules that I have imported. Like, let's do something. Let's kill this. I'm going to remove the right, I'm going to outright permissions for group and others on the .gaci. And what that's going to cause is I'm not going to be able to load the GACI file because the REPL, like GACI, pays attention to that. So I'm going to execute stack REPL, etc. lib in here. And you will notice there's two warnings at the very top over there. So let's go back to the warnings. The first one is saying .gaci is writable by someone else, ignoring. The second one is saying the ubuntu.gaci, Ubuntu in this case is my user, is writable by someone else, ignoring. And you may notice that the behavior is a bit different altogether. So first thing is, when I write a 5 in here, it doesn't show me the timings or show me what's the type. It also shows me all the modules that I have imported and loaded on this REPL on the prompt, which is something that is not, you're not able to work with this when you have a really big project. So one of the first things that I do on my GACI is set the prompt to something more bearable like this, right? As soon as I do that, things work. So you may notice here on the right side that I'm just basically writing commands to GACI as if I was in the REPL. I do a few things. I change the prompt. I remove implicit prelude. I enable overloaded strings. I enable scope type variables. I show all the warnings always. I remove the type defaults warning because it's really annoying when I'm doing REPL development. I define a constant called GACI. What is this constant for? If I go and I look up at a file in here, I'm able to do the CPP pragma and look up for that symbol. So I do define the symbol on my .gaci so that whenever I'm developing on the REPL, sometimes there's certain things that don't work as expected or need to be tweaked. I use this pragmas in order to change those behaviors that only work on the REPL. So that's what this guy is there for. The -d is to define and then the value. Then I do set plus s, set plus t. The REO package, because I don't like the default prelude, I always rely on the REO library to do my prelude for me. The package pretty simple to pre-print data structures. And I also set interactive print to pprint. So this is basically saying every time something comes out of the result, if it is too big, pre-print it, right? These things are pretty useful. So I'm going to go ahead and write down the -w and also the one for my home. And as soon as I do stack REPL, etc. lib again, you may notice that those ugly warnings are gone. If I go here, it's going to set load a GACI configuration from this place, and then it's going to say load a GACI configuration from this other place, right? So it starts from the closest GACI to the furthest GACI. First, it loads the one from the project, and then it loads the one from my home. And if I go and I say, for example, I want to get a raise from 1 to 100, it actually prints the thing in a pretty printing fashion because I modified the pretty printer on my .gaci, right? So it's really nice utilities that are well known, not well known, but they're useful. Okay, so now let's go back a little bit, and I'm just going to rush through this because we started to run a bit out of time. Whenever you're doing development, you want to do a reload of the module as you develop it, right? So we were looking at the REPL a second ago, how how we did development of a module and then hit reload and execute tests as we go. This works great, but sometimes people do it from the very top of the project. Whenever you do this on a really big project, the time that it takes to reload things is pretty slow. I'm going to show you really quickly how that looks like. So I have in this module, in this tab, the Cardano project. It has around 1,756 files of Haskell. And whenever you're executing a command in here, you can tell it's a pretty big project. So I'm going to go and do JCI options in here. And this is the time that it's going to take to load this project when you have all the sources compiled already. It's going to, whenever you don't specify a target and you have multiple targets that you can load from, Stack REPL is going to ask you to pick one. In this case, I'm going to pick the number 2, and that's going to take a while to load. As you can tell, it takes a while. Okay, so a lot of times what people do on development with REPL is you have the main of your application loaded on the REPL, and then you modify a file, and then you hit reload, and that automatically compiles all the things that depend on this module in order to get a new main fresh and going, right? You may notice also that I have object code, and as soon as I hit reload, it's doing .o in it. Remember I mentioned that when you're doing compile object code, it's slower to get compiled modules, and it's faster to get interpreted modules reloaded. There's a gotcha though, that when you're using bytecode, if you reload everything again, you're going to lose all the compiled cache that you have, and you will have to reload that every time. So ideally, you want to modify you want to compile everything in object code and then change to bytecode and focus on a particular module, right? So in this case, given that I'm working on requests, I'm just going to say I want to work on, let me see, show paths. I have a bunch of things in here. So I want wallet new. So it's going to go wallet new, and I'm going to go source Cardano wallet API requests.hs. So I go and load this, and you see that's pretty fast, right? I can keep modifying this thing in here in various ways, and then I just hit reload in here, and things automatically, save, reload, things automatically work, right? So compare this to how much time it took to load the reload on the main, and how much time it takes on the module. And you can see how you can, even though you have a big project, start using the REPL to work quickly in it, right? That's the recommendation I would give when you're working on large projects, to always load the module that you're working on and reload just that module instead of reloading the whole test suite module or reloading the whole main project, because it becomes really expensive in that way. We talked about a bit about this before. We showcase how Stack ID targets work, and also how can we load the test REPL or the test suite on the REPL and run both the library and the test suite at the same time inside the REPL. So to summarize JCI, the great thing about JCI is that you have a REPL here there. You can experiment with the code as you go. You can write down things and tweak them, interact with them really quickly. You can run test suites in the REPL, which is really useful. But there's no automatic load or of changes when the file saves. This is particularly true when you're only using Stack REPL. However, there are tools that allow you to use the REPL inside your editor in a way that as soon as you modify a file on your editor, it will automatically reload it on the REPL for you. So there are ways to automate this. It's just that with the tools that we're giving you today, which are the editor agnostic ones, there's no way to do it. can be pretty slow on large projects. So if you are using, like if you're developing a project as massive as, say, Cardano, you will have to be really conscious about the object code and the bytecode settings, and also be really mindful of reloading only particular modules. This large project slowness can be addressed. Okay, so just to finish up, we're going to go quickly into GACID. So GACID, it's a combination of both the compiled approach and the interpreted approach. The way it works is simple. You just specify the GACID command with a command argument. Let me just do that in here. And what it will do is load the REPL, and it's going to do the type checking on that REPL inside. So every time you're modifying this file, it's going to compile and show you something. So you may notice that this is insanely fast, especially for small projects. You can also do something like execute certain actions inside that REPL. So say, for example, I want to, for some reason, every time the code loads, I want to execute hello world in there, because you only live once. So it tells you there, oh, you have a warning with trace.io, because trace.io has a deprecation warning, hello world. So every time you load that, it's going to show you the result of that. So this is really great to run, say, tests inside the REPL. The same way you were running the tests inside the REPL on the previous section, you can define a command in the test argument that run that particular HSpec spec. The problem with that is that as soon as you need to modify it to be something else, you have to kill the GACI REPL and run it again with the modify commands. That's like just for the sake of completeness, I want to show you how GACID works on a Cardano, so you can see a difference. What's the difference in there? So GACID command stack REPL, and let's just do Cardano SL wallet new lib, just to get one particular target. Otherwise, we're going to be here for a while. So you may notice that this will take a while. It does the interpretation of at least 146 modules in order to get that going. And compare this to the way we were running it before with object code. We didn't have to go through the interpretation of all these modules when doing object code, because the object code was already generated and it was just linking all of that. Right now, it's going and interpreted all the modules that you require because it's doing bytecode. If I was doing object code in the stack rep and the GACID command, it will have used a .o, but I also wanted to showcase you how expensive it is to run the bytecode mode on big projects like this. I think that's more or less what I had as contents. Okay, but first, summary of JCID workflow. Faster than the compile approach. It's really, really fast. You come back to the problem of you can experiment with on-the-fly code. Like you cannot tweak code and see how it behaves. You cannot see the types. So it's really fast, but it's really limiting in terms of interaction with the code. Becomes rather slow in large projects, as we've seen here below. And the great thing is that saving a file automatically recompiles the code, recompiles or reinterprets the code, however you set up the mode. That's a really important feature. So this is all the content that I have for today. You can follow FP Complete or me on Twitter. I write sometimes on blog romangonzalez.ca. Thank you very much.
So Roman, firstly, honestly, I learned a lot from this webinar as well. Thank you very much for doing it. You're getting some thanks from the audience as well, but that one is personally for me. There are also some requests for your slides and for your .ghci file. Would you be able to make those available after,
Sure.
after this webinar?
Sure thing.
Cool. Okay, I'm just seeing thank yous coming in right now. And yes, everyone who is asking, this video will be made available once assuming the recording actually worked correctly this time, we'll make the video available. Are there any other last questions before we go? I don't think so. So Roman, thank you again for giving this presentation. Audience, thank you everyone for attending. Thank you for the great feedback and questions throughout. And stay in touch with FP Complete. We'll be making more webinars and we'll be in touch when they're ready. All right. Have a good rest of the day, night, or wherever else you happen to be.